There is a border you can point to in space. It is not a wall, but light's last arrival. Bottom line now, beyond that border there is more universe. Not emptiness, not nothing, just regions whose light can't reach us. Picture a glowing sphere around Earth, marked by the oldest light. That is our observable universe, defined by time and expansion. Beyond it, galaxies keep going, stars keep burning, space keeps stretching. We simply cannot see them because light needs time. That boundary grows every second, while new regions slide beyond. So the mystery is not a void, but perspective. Stay with me, and the picture will get crisp. Start with a night on a cold desert plateau, stars blazing. You tilt a radio dish at the sky's faint background. That hum is the cosmic microwave background, the oldest visible light. It sketches a horizon, like fog limiting a car's headlights. By beyond the universe, we mean beyond that visible patch. We do not mean outside space, because space includes everything. Care matters here because sloppy wording creates fake paradoxes fast. Light has a speed limit, and the universe has age. Space also expands, carrying distant galaxies farther between each wave. Mechanically, that combination sets a shell where light reaches us. Inside the shell, we can form images and maps. Outside it, things exist, but their signals cannot arrive. Not yesterday, not ever, if acceleration keeps stretching distances faster. Rule of thumb, our horizon radius is about 46 billion light-years. That is larger than the universe's age times light speed. Expansion stretches space itself, so light's path lengthens en route. Example, in real terms, a galaxy now beyond reach still exists. Its stars forge elements, while its supernovae blast heavier atoms. We will never see those events because distances outrun light. Telescopes cannot cheat geometry, even with perfect mirrors and sensors. One sentence recap, beyond the observable patch is still universe. It keeps going whether or not we ever witness it. This framing removes confusion about edges, borders, or outsides entirely. The universe is the whole, by definition of the word. Beyond our view means farther away, not outside existence itself. Distance plus expansion hide it, like surf swallowing distant footprints. That is the stage for deeper possibilities we can test. Now shift from a map to a stopwatch ticking in space. There are two horizons people mix up constantly. One shows what we see today, the particle horizon. The other shows what can ever affect us, the event horizon. In plain words, an event horizon is a forever barrier. Signals outside it will never reach us, not even eventually. Dark energy drives this barrier because space expands faster with time. Galaxies beyond a certain distance recede faster than light. That does not break relativity because space itself is stretching. Mechanically, wavelengths stretch and energy thins as distances balloon. Photons become undetectable, then impossible to ever arrive. Here is the shocker: most galaxies are already beyond our event horizon. Estimates suggest only a few percent are causally reachable now. Everything else keeps existing, while slipping permanently out of touch. Example, in real terms, Andromeda remains reachable for billions of years, but a bright galaxy 10 billion light-years away is lost. Its light today will redshift forever, fading into undetectable cold. Tiny test: if you pause expansion, the barrier disappears. Turn it back on, and the barrier reforms immediately. One sentence recap, not empty beyond, just causally disconnected forever. We live in a widening island while the shoreline runs faster. That picture sets up the next possibilities we might test. Our island includes roughly 2 trillion galaxies within the observable patch, yet only a fraction can ever exchange messages with us. That is the sober scale behind the phrase "not empty." It is crowded out there, but causally silent to us. Shift your eyes from distance to shape, the room itself. Space might wrap like a hall of mirrors with hidden seams. In plain words, the universe could be finite yet edgeless. You return to where you started without crossing a border. Why care? Edges suggest outsides, which invite fake mysteries. Topology sets rules for how directions glue together across space. In practice, points on opposite faces are the same place. Light loops around, creating repeated patterns in the sky. You would see matching circles in the background's temperature map. Astronomers searched for that tell, with Planck's exquisite all-sky data. They found no convincing matches across many proposed shapes. That pushes any wraparound size larger than our visible diameter. Example, in numbers, the shortest loop must exceed our horizon today. Otherwise, we would have seen those twin circles already. So if space is compact, it is bigger than our patch. Beyond any apparent border sits you again, further around. Common mistake is imagining a floating bubble in pre-existing nothing. There is no outer air here, only self-connected geometry. Planes do not need edges when the surface is a sphere. Likewise, space can loop without a surrounding container at all. One sentence recap: beyond may literally be this space repeated. No outside required, just a clever global stitch in geometry. Future surveys of polarization could tighten those bounds further. If matched circles appear, geometry would announce a wrapped cosmos. If not, the fundamental domain simply lies larger than we see. Either way, emptiness does not enter the explanation anywhere. Now zoom to a single spark forming inside a frothing field. That picture comes from inflation, an early burst of expansion. In plain words, empty-looking energy made space double many times. While most regions cooled, some patches kept inflating like runaway yeast. That process never ends everywhere, so new bubbles keep appearing. Each bubble is a universe with its own physical details. Why care? Beyond our bubble, others may crowd the foam. Under the hood, quantum tunneling triggers pockets where inflation switches off. Their walls race outward near light speed, freezing space behind. Inside, hot particles form, then galaxies, then maps like ours. Two nearby bubbles could collide, leaving circles of disrupted temperature. Searches found no decisive hits across many algorithms and skies. Still, eternal inflation is hard to stop, given simple ingredients. Example in numbers: one doubling after another yields staggering growth. After only 90 doublings, one grain grows past our patch. Beyond does not sit empty here, it froths with almost endless creation. One sentence recap: bubbles make neighbors plausible, even if unvisited. We might someday spot a scar or constrain the chance. Until then, this remains bold but logically grounded speculation. The key idea survives either way. Beyond is full of possibilities. The driving energy is like tension, stored in empty-looking space. Release that tension locally, and a hot beginning erupts. Keep it elsewhere, and inflation keeps stretching the background wider. That contrast yields a cosmos that is patchy on grand scales. Switch scenes to a quiet lab, lasers tracing careful lines. Physicists test whether gravity leaks into dimensions beyond our three. In plain words, the universe might be a membrane in bulk. We float on a three-dimensional sheet inside a larger space. Why care? Beyond us would be real directions filled with fields. In practice, extra dimensions can be curled, wide, or warped. Gravity can wander that bulk, while light stays trapped on ours. If so, the inverse square law bends at small distances, or black holes would evaporate faster by radiating into bulk. Experiments push hard, using torsion balances and micro-mechanical oscillators. Tabletop tests now see no deviation down to fractions of a millimeter. Particle colliders likewise find no missing energy from wandering gravitons. Gravitational waves also restrict exotic leakage with their clean propagation. Example in numbers: current bounds squeeze extra dimensions below micrometer scales. Warped models survive, but simple large dimensions face strong pressure. One sentence recap: beyond might be literal directions, yet still hidden. If found, beyond would not be empty, it would be roomy. For now, precision tools keep narrowing the lane for discovery. Astrophysical bounds arrive from stars cooling by hidden channels. Too much leakage would overcool white dwarfs and supernova cores. Observations match known physics, so any new path must be tiny. Future interferometers could probe waves bending through a warped bulk. If a signal lags strangely, geometry outside might be responsible. That would turn beyond from poetry into calibrated measurements. Picture a star collapsing, its core falling through catastrophic densities. At the center, theory predicts a point where math explodes. In plain words, equations hit infinity and understanding breaks. Some ideas replace that point with a bounce to expansion. The new region disconnects, becoming a baby universe inside. Why care? Every black hole could seed fresh cosmic space. At extreme curvature, quantum gravity fights further collapse. Pressure rebounds, geometry tunnels, and a new domain inflates. From our side, nothing escapes because the horizon hides everything. From the inside view, a whole universe opens and grows. Example in numbers: our universe could have sprouted similarly long ago. If true, parent universes might favor black hole-friendly physics. Then offspring with more black holes would dominate the family tree. That idea goes by cosmological natural selection due to Smolin. Evidence is thin, and the math remains challenging to test. Yet it solves the emptiness worry: beyond could be rebirth. One sentence recap: black holes may pinch into brand new outsides. our cosmos might sit inside a much older parent background. And our black holes might be cradles, not dead ends. Future signatures could include subtle imprints in primordial gravitational waves, or statistical patterns in constants that favor copious stellar collapse. We do not have those yet, but watching continues. Meanwhile, black holes remain laboratories for extreme curvature and quantum fields. Whatever hides inside, beyond here is not simple nothingness. Step back to sheer emptiness, the darkest patch between galaxies. In plain words, even that is not truly empty. Quantum fields fluctuate everywhere, seething with brief particle pairs. Dark energy also pervades space, pushing galaxies apart faster. Why care? Beyond any horizon, these fields continue uninterrupted. Here is how it works. Uncertainty lets fields borrow energy briefly. Pairs appear separate slightly, then annihilate back into fields. With gravity present, that froth shifts how space itself curves. Meanwhile, dark energy acts like uniform tension in spacetime. Its density is about 7 protons per cubic meter. That sounds tiny, yet it dominates the universe's future. Example in numbers, about 68% is this strange component. The rest is dark matter and ordinary atoms making structure. So beyond any map lies spacetime, humming with activity and energy. One sentence recap, the phrase empty space is a misnomer. Everywhere holds fields, fluctuations, and a gentle push outward. Beyond our horizon inherits all of that restless content. No matter if galaxies are unreachable, fields still live there. Detectors on Earth already sample this ocean in subtle ways. Casimir forces appear between plates from modes squeezed out. Lamb shifts move electron energy levels due to field jitters. These effects prove the vacuum has structure, even without particles. So when you ask what lies beyond, remember this texture. The outside is busy, not barren, at every imaginable scale. We started at a border that looked like the universe's edge. It was really a horizon, set by time and expansion. Beyond it was never empty, just farther than messages can travel. Sometimes beyond is you again, if space quietly wraps. Sometimes beyond is neighbors, if inflation sprouted many bubbles. Sometimes beyond is directions, if extra dimensions bend gravity's path. Always beyond is fields and energy, shaping expansion and fate. So the headline stands, outside is not empty at all. If this reframed your mental picture, join me for more. I drop videos that respect curiosity and cut jargon clean. Tap subscribe to keep exploring and share this with a friend. Next time we will chase time itself through a black hole. Until then, look up and know the outside is busy. Your horizon is growing, and so is the known story. New maps, sharper detectors, and stranger ideas will collide. Some will fail loudly, and the survivors will teach. That is science doing its best work in public. Thanks for hanging out here under a very large sky.